Required: find the value of radius r and the length x of the regular hexagon.
Label some points of intersection of the regular polygon with the circle as shown in the diagram. Join straight lines BC and QE respectively, and label point M the midpoint of line LZ.
Join line BO equals DO equals radius r of the circle. Interior angle of hexagon equals 120 degrees. This implies that angle BQE equals angle BQL divided by 2 equals 120 degrees divided by 2 equals 60 degrees. But angle BQE equals angle KBC equals 60 degrees. Corresponding angles. Also, angle QBC equals angle ECB equals 120 degrees. QBC is a regular quad. But reflex angle BOD equals 2 multiplied by BCD equals 120 degrees multiplied by 2 equals 240 degrees. From triangle B,
angle BOD equals 120 degrees. Hence, from triangle BOD, since BO equals DO equals radius r, using cosine rule we have, and solving for a square. Our square equals 13 squared divided by 3. Take the square root of both sides of the equation. Therefore, our equals product of 13 and square root of 3 all divided by 3. We can find GK using cosine rule, which gives us GK to be equals to the product of x and square root of 3. GOM, we use Pythagoras' theorem to find the square of r. Solving for x, we have that x equals 8 centimeters and x is not equal to 0.
Consider the given figure. Use two methods to find the value of angle x. For regular polygons, the formula for the interior angle is the product of 180 degrees and n all divided by n, where n equals to the number of side of the polygon. For the green polygon, n equals 9 sides. Thus, Interior angle is 180 degrees multiply by 9 minus 2 all divided by 9, which is equals to 140 degrees. For the blue polygon, n equals 6 sides. Thus, interior angle is equals 120 degrees. We need to make some construction to find the value of angle x. Label B, C and D, join line C, D such that line C, D bisect the blue regular hexagon. Line B, D, is a transversal line that subtends angle 60 degrees each in the base of the two different regular polygons. These angles are corresponding angles. Label point E and draw a perpendicular line from it to the red line such that 140 degrees equals the sum of 90 degrees and 50 degrees. This implies that angle B equals the sum of 40 degrees, x and 60 degrees, which equals to 140 degrees. Solve for x and we have that x equals 40 degrees after simplification. Therefore, x equals 40 degrees. Second method. Label point Q and draw a perpendicular line from it to the red line. Also, label G and join line D, G. Consider irregular pentagon. Its boundary or region is indicated by two arrows. The sum of interior angles of pentagon is 180 degrees multiplied by 5 minus 2 all divided by 5, which equals 540 degrees. This implies that the sum of 60 degrees, 80 degrees, 240 degrees, 120 degrees and x equals to 540 degrees. Simplify and make x the subject of the formula, and we have that x equals 540 degrees minus 500 degrees, which equals to 40 degrees. Therefore, x equals 40 degrees.
Two regular polygons are arranged as shown below. If the area of the inscribed circle is 64 pi centimeters square, what is the value of x? Hence, find the length of the yellow line y. Leave your answers to 2 decimal places. Label B, C and join BC. BC equals the product of 2 and R are the radius of the circle. Equating the given area of the circle with the equation of a circle and solving for radius R, we have that R equals 8 centimeters. Thus, B, C equals E, D equals 16 centimeters. Label G and join GE. Label H and K. Triangle labeled DHE equals to triangle labeled GKE. These are similar triangles. Line E, D equals line G, E which is equals to 16 centimeters. Thus, GE equals X equals side length of the regular pentagon. Therefore, X equals 16 centimeters. Label I, J and join EJ. From triangle labeled JEI we can find line EJ. Using cosine rule, angle EIJ equals to 108 degrees. Angle J is an interior angle of regular pentagon.
Label Q and M such that line Q, M equals to line J, M equals to 8 centimeters. Line E, M bisects the pentagon. From triangle EIJ, we use cosine rule to find the square of line E, J as shown in equation 1. The square of line E, J equals the product of 2. The square of 16 and 1 minus cosine 108 degrees, which is equation 1. From triangle labeled EMJ using Pythagoras theorem, we have that the square of line EJ equals to the sum of the square of line EM and the square of 8. We call it equation 2. Recalling the value of equation 1 and substituting it in equation 2, rearranging the equation, we can now solve for the square of the line EM. Find the square root of the equation. We have new equation for line EM as shown on the screen. But line EM equals the sum of line of ED and DM. Rearrange the equation and solve for line DM, as shown on the screen. Simplify and we have that line DM is approximately equals to 8.6214682,974 centimeters using a calculator. Therefore, line DM equals to 8.62 centimeters to 2 decimal places, which is equals to the required length of the yellow line. Y.
What is the radius, r, of the circle from the given figure? Choose the correct option. Construct center O, join the vertices of the smaller and larger triangles to the center O. Let beta be the angle subtends at the center by each apex of similar small triangles. This implies that the larger triangle apex angle or angle it subtends at the center O of the circle is equals to 120 degrees minus beta center O of the circle. Consider one of the similar small triangles and use cosine rule. We have that the square of 11 equals the product of 2, the square of r and the difference between 1 and cosine beta. Simplify this result and solve for the square of r. That is, square r equals to 121 divided by the product of the 2 and the difference between 1 and cosine beta. We call it equation 1. Also, consider one of the similar larger triangles and use cosine rule. We have that the square of 26 equals to the product of 2, the square of r and the difference between 1 and cosine 120 degrees minus beta. Simplify the result and make square of r the subject of the formula. We call the equation obtained by the square of r equation 2. Equate equation 1 and equation 2. Call it equation 3. Simplify equation 3 by using trigonometry identity to resolve cosine 120 degrees minus beta. Before substituting the new value of cosine 120 degrees minus beta, cross-multiply equation 3. Multiply the equation obtained by 2 to clear fraction. Our new result is shown on the screen. Combine like terms. After combining like terms, we simplify the result to have that 1473 multiplied by cosine beta equals to sum of 1110 and the product of 121, the square root of 3 and sine angle of beta. Using trigonometry identity, we convert cosine beta to sine beta and substitute in the last equation obtained for cosine beta as shown on the screen. Square the equation, expand the brackets and multiply out the terms with their outside common factors, respectively. Combine like terms, rearrange all terms in one side of the equations. Simplify the equation and solve for sine beta using quadratic equation formula. Substitute coefficient of the terms formed by the variable sine beta in the quadratic equation. We assumed you already known the general formula used to solve quadratic equation. For that reason, simplify the equation in sine beta as shown on the screen. Take positive value of your result as or because sine beta is positive in the first and second quadrants and we are solving for angle less than 180 degrees, sum of angles in a triangle. This implies that, simplify your result, sine beta equals the product 231 and the square root of 3 divided by 722. Use trigonometry identity to find the value of cosine beta since we have already obtained a value for sine beta. This value of cosine beta is shown on the screen. Simplify the value of cosine beta and we have 601 divided by 722. In equation 1, substitute the value of cosine beta obtained. Find the square root of the equation. Are the radius of the circle equals the square root of the product of 121 and 722 divided by 242. Simplify and we have that are equals to the square root of 361 which is equals to 19 units. Therefore, the radius, r of the circle is equals to 19 units. Option C is the correct answer.